Hi everyone, we're going to start with chapter 4. I know we didn't get a chance to do the chapter 3 test. We'll figure out it, I guess, if and when we get back to the school, but for now we're going to work on chapter 4, and I'm going to give you guys just the basic stuff, the basic information that you need. Okay, so the title is vertex form of a quadratic function, and there's just 3 examples for today. So example 1 is kind of a review from stuff we did in earlier chapters. So with the function here, we have the a, h, and k value. This is in vertex form. We're going to determine the following. So first of all, we want to know what the direction of opening of this function is. So it might be a good idea before you even start this question to just do a quick sketch of the function. So because it's 5, 7 as the vertex, remember wacko bracko, so 5, 7, and the a value is positive 3. Just a basic sketch of this parabola shows that it's opening up. Okay, so from there, the direction of opening, because a is a positive 3 value, any positive a value means the parabola opens up. The axis of symmetry, so I kind of did it on the diagram here. The axis of symmetry is an imaginary line that cuts the parabola in half. This has an equation, and the equation is simply, if you want to go right from the original function, it's just whatever the h value is. So h has a positive 5 value, so this line right here, the equation of it is x equals 5. Okay, so you can either figure it out from the parabola, or you could just memorize the way to do, or the way to put this into the to answer this question. C, we're looking for the minimum value. Because it has a lowest point, we're looking for that value. Well, that value is simply the k value. That's the lowest point, which is a y equals 7 equation. The vertex we know from h and k is positive 5, positive 7. And we go back to the domain and range. The domain of any function is x element of the real. And the y is y such that y is greater than or equal to positive 7. It goes bigger than 7. And that's basically how to fill out those ones. So in the homework tonight, or the work today, there's a chart. You're going to just have to fill that out accordingly. Okay, the second example, determine the zeros of this function. So before we took the little break, we did zeros of a function. We talked about where the parabola touches the x-axis. So we can do that right from an equation. So here's the function x minus 5 squared minus 36. So to find the zeros, again, you set it equal to 0. I wrote that just in the margin here. And then from there you solve reverse BEDMAS. So bring the 36 over, becomes plus 36. The opposite of squaring something is to square root it. So if you square root one side, you got to square root the other. So the square root of all this just becomes the x minus 5 and the square root of 36. Now the square root of 36 has 2 values. It has positive 6. And it has negative 6, because negative 6 squared is also 36. So here's where you branch your 2 answers. You set 1 to positive 6, 1 x minus 5 equal to negative 6. And then by bringing the minus 5 over, becomes plus 5. And you solve your 2 x intercepts or zeros or whatever you want to call them. So here we have x equals 11 or x equals negative 1. Okay, so you're solving from reverse BEDMAS and then branching your 2 solutions. Okay, so you have a couple of examples to try that out. Okay, and then the third one, determine the equation in vertex form given the following information. Given the vertex is negative 3, negative 6, and it passes through a point negative 1, positive 2. Okay, so we go back to our original vertex form with all the letters. The first thing you're going to do is input the vertex, the h and the k, negative 3, negative 6. Well, remember that wacko bracko, the negative 3 turns into a positive 3, and the minus 6 stays where it is. So that's where the vertex goes. It's h and k. And then the point negative 1, positive 2. The negative 1 is the x coordinate. The positive 2 is the y coordinate. And again, we got to solve for a. Okay, so once all that stuff is in, we just begin to simplify and solve. So the -1 plus 3 gives you +2 inside the bracket. 2 squared is 4, so all of this becomes 4a. Everything else stays the same. Then the -6, you bring it over, becomes +6. 4a is equal to 8, and divide both sides by 4, which gives you an a value of 2. And then you write the equation. F at x, a is equal to 2, and then you have your vertex form, your h and your k. Leave the other stuff alone. Okay, so that's how you write the equation in vertex form given the vertex and a point. And there's a couple of examples for you to do for today's work. Okay, so I made a lot less questions for you. On page 204, it's number 4, 5, and 8. I'm going to try to put the Nelson textbook online for those of you that didn't bring your textbook home. For now, this is what page 204 looks like. Number 4 is the chart. Number 5 is determine the zeros. And then number 8 is write the equation in vertex form. You can also expand it to standard form, but that's not required for now. So all you got to do is just stop here at vertex form. Don't worry about the standard form. Practice a few of those. So you're going to write it out on a piece of paper. You're going to submit it at the end of the week in the assignment for chapter 4 section. And I will be back tomorrow with the next lesson and the next set of questions. Okay, good luck everybody. Have a good day.